Yo, what's up, people? Today, we're going to learn how to code. We've been doing that already. We're going to learn about inheritance and object-oriented programming. Cool stuff, right? You're like, I don't even know what that means, man. Okay, so what I'm going to do is I'm going to delete my canvas here, and I'm going to go to my main camera here. This is from the last lesson. I'm just going to clean it up. If you have a new project, that's fine. I'm going to go to my assets here and create a new C# script. And we're going to call this... well, what are we going to call it? Well, let's talk about this. I'm going to call this thing humanoid, and you'll learn why. Humanoid. Okay, so object-oriented programming is really cool. It's the notion of categorizing everything into objects and being able to instantiate those objects and reuse them. And here's a perfect example. Imagine that you have a factory. We talked about this once before, a car factory, okay? And you need to produce cars. So what you could do is someone creates a blueprint. Your engineers create a blueprint, okay? And that's a class. So let's open up our humanoid here. See how it says class here, public class? Okay, that's a class. So the blueprint is a class. All the code you write here is your blueprint, okay? You with me so far? But then your factory actually has to produce the cars. So it might make a truck. It might make a car, it might make an SUV, and different types of cars, but they all have similarities and differences. But you know, if you're writing this in code, you wouldn't want to have to rewrite the code every single time. And so that's the notion of object-oriented programming. You break things out into objects and you make them reusable. So let's see it in action here. So I've created a class called humanoid. Imagine that we are creating Diablo 4. Okay, we're just starting out writing our first lines of code. I'm an employee at Blizzard. I'm like, yeah, I get to create my new class. Well, we know that a human player, okay, and let's say an enemy, like a zombie, okay, it's still kind of humanoid, right? It can stand up, it can walk, and it has some similarities, right? Now, you're a player, you're controlling your player, but you're not controlling the zombie, but both the player and the zombie have similar things, such as they can both have an attack damage, and they can both have health, right? We know that the zombie, after a certain amount of damage, will die, and we know that he inflicts a certain amount of damage. We also know that both will have a move speed. The zombie can move, and the player can move. So there's definitely some things that, even though they're different, the zombie and the human, the player, they share in common. And this is where object-oriented programming shines, okay? So you create classes, and then classes can inherit features from other classes. In this case, our humanoid character is inheriting from monobehavior. Okay, pretty cool. And what's interesting is we don't actually have to inherit from anything in a class. Well, let's take that off here. Take this off and take this off. Actually, I'll leave it there. What happens when I get rid of monobehavior? Well, let's go look at Unity. Come on, let me save it here. Okay, and then let's drag this class onto the main camera. Okay, look at this. Can't add script behavior humanoid. The script needs to be derived from monobehavior. So it won't work. I can't drag my classes into Unity unless it inherits from monobehavior, because monobehavior is a series of classes that Unity has written for games, and it includes things such as the void, the start, and the update and such. Pretty interesting, huh? But you don't need to have it if you're not going to use it. Okay, we'll put it back if we need to use it. So there's a class. And let's go ahead and go for our example here. We have a humanoid object, okay, which is, a zombie, a player, whatever. It could be anything. And so we talked about a few things. So we're going to say private int health. So there's health, right? And private int. And let's go ahead and say attack damage, because both a human and a zombie or whatever can have attack damage. What was the other one? Movement speed. Private. Probably float movement speed. It's pretty cool. And probably each of these, both the player and the enemy, can do similar functions as well too, right? They can attack. So we can say public. The reason I make it public is because we'd want them to be able to perform the operation. Someone else should be able to call this, I would imagine. So public void attack. Okay. And then public void. So maybe some code to move. So move. And then what else? So attack and move. Is that all they can do? Attack, move. They could die. Both of these can die. Public void die. Pretty cool, right? I like it a lot. I think it's really awesome. So now, let's say that we want to expand this further. So we know we've got some base things going on here. This is our class humanoid. This is looking great. And so what I want to do now is I want to create another class for the player. Let's just get the player started, okay? So I'm going to go right-click the assets here and create a new C# script, and we're going to call this player. I'm going to open it up. And instead of inheriting from mono behavior, what if we inherit from humanoid? Like so. Interesting. We can get rid of these. Okay. This is really cool. So now I've got a humanoid character, but notice how we got move here, die here, and attack here. There's no code. Do you think that a player would move faster than a zombie? I think they would, for sure. And so I think even though we know that both are going to need these functions here, they both might implement them in a slightly different way. And here's the beauty of object-oriented programming. So let's talk about how we're going to do that. Again, so a player needs to move and attack. Humanoid, we've got those functions here. Okay. So let's go ahead over here and figure out what we do. So we can actually just say public void, let's say move. Okay. We've just written the same exact function that's over here as we did over here, even though we're inheriting here. Let's go look at Unity and see what it says. Player.move hides inherited member humanoid.move. Use the new keyword if hiding was intended. Well, we don't want to hide. We want to use the parent function. Okay. So for instance, let's say in our move code here, let's put back the mono behavior because we want to access Unity's functions now. Okay. So let's say in the move function, we want to say transform.translate. There we go. Transform.translate. And we'll say vector3. This is how sometimes you move things. Vector3.forward times, let's say, time.delta time. Okay. So that's just one way to move things in Unity. You don't have to understand this, but my point is we've got some code in here to move. Okay, vector3.forward times.delta time. That's the typical way that you move forward. Okay, yeah, that looks good. It looks good to me. And then movement speed right here. Yeah, let's say times.delta time. Yeah, it looks good to me. Okay, so let's say that's how we move here in the humanoid class. In fact, let's actually go over here to our script or Unity and create another class for the zombie. So let's right click and go to create C# script for zombie. Let's use the zombie for an example instead of a player. Okay. So zombie, let's get rid of the update stuff here and let's have this inherit from humanoid like so. Okay, so humanoid has this move function. Zombie needs to have a move function. So public void move. All right, it's going to give us the same warning. So how do we actually make it so we can call the parent class, but also do our own thing as well too? Well, we need to change around our function here in the humanoid class just slightly. Okay, what we're going to do is instead of just saying public void get info, we're going to say public virtual. And what the keyword virtual does, meaning it means that your classes will be able to override it, but you can still call it from the child class if you want. That's all it does. It lets your child class like zombie call it without getting that warning. Okay, no big deal. And then all we have to do down here is actually just say public override. So in the parent class you say virtual, in the child class you say override. And what's going to happen is if we call base.move, it is actually going to call the code right here. So as a child class can call its parent class function like so, base.move. And so what's going to happen is it's going to call this code here. It's going to keep moving it. But let's say with the zombie, we want to do our own code. So we want to move it a little bit, but then we also want to move it again in a left direction. Okay, so here we're moving forward, but the zombies, they kind of stagger. So so the base.move is going to move it forward. Both the players need to move forward, but in the case of the zombie, okay, we'll do another transform.translate. and it's the transform with a lower t here. Translate, and this time we're going to say vector3 dot left and times, we'll say 3 times time dot delta time, and the 3 is just like maybe the speed, and time dot delta time is the time between frames. Anyway, again, this isn't about the Unity movement function, it's about classes here. So our zombie, anytime the move function is called, it's going to move it. So it's going to call the parent class move function, which is going to move it forward, because the zombie's a little bit staggering, he's lost part of his limbs. He kind of goes to the left a little bit when he walks. So transform.translate. So we add some custom code. Whereas on the player, we can actually delete this altogether. Look, we maybe think the player's movement code is just fine, so we don't have to do anything. So what we've just done is we've saved a lot of time. We didn't have to rewrite this code here for every single player. Imagine if we didn't inherit every single player or character that needed to move, we would have to rewrite this code right here, this line of code. But imagine if it was 100 lines of code. We'd have to rewrite it over and over and over again. But we intelligently used inheritance and object-oriented programming to use the base class's movement forward, and then on the zombie, add some additional functionality, which I think is pretty cool. If we didn't call base.move, it would not call the forward movement on the humanoid class. And that's optional. You don't have to if you don't want to. But in this case, we wanted to. We wanted to inherit that ability, which I think is pretty awesome. There's other things we can do as well, too. We can have our own function, let's say, in the zombie class. We can call this public void, puke, acid puke, because, zombies puke acid for some reason. Even though they were once human, now they have acid. Maybe it's just acid reflux. Okay. Acid puke, not acid zombie. Acid puke. Okay. We want to puke acid, right? So let's go look at the humanoid. So we've got health, attack damage. Okay. Well, attack damage probably is great for a base amount, but, let's say that's its main attack, but acid puke, kind of probably has a poison effect. You're gonna get a long-lasting damage. So in our zombie now, we need something new. Let's say private, and we're gonna say int. And we're gonna call this poison damage, and maybe this is just like 3, like it just adds it over a certain period of time. So now what we can do, okay, is we can acid puke attack. That's what I want to say. And let's say instead of returning nothing, it actually returns the attack damage. So it's gonna return an integer. So the acid puke damage, okay, we can take the base damage from the parent class, attack damage, and then add a modifier, which is the poison damage. So we can return, okay, so we return the parent class's attack damage. So return attack. It's not there. Why though? Shouldn't a child class have everything available to it that is available in the parent class? The answer is no. Okay, and here's the reason why. We're using private, which means only this class can access it, but we need child classes to be able to access it. So instead of private, if you want these variables accessible from children classes, you just change them to protected. No big deal. Protected, 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 which means it's private in here, but the children classes get access to it as well. So go back to zombie, and now we can say attack damage, and it's right there. Look, you don't see it anywhere on this screen on this class, but it's over here. We're accessing the parents thing here, which I think is pretty awesome. So we say attack damage plus poison damage. So again, we have a very custom function here, but we're using the parent class's information. Okay, so acid puke damage. This is great. Now let's go to our player, for instance. Doing the same thing, we could say public override, and then we could say, we don't have the attack yet, right? So we can go over to our humanoid and make that one virtual as well. So public virtual void attack. Okay, and then public override attack. Look at that, it already adds in the base attack for you, which is pretty cool if you want to call it. In our case, let's say we don't want to do this, and we want to completely override it. Okay, and then what we could do is actually this attack should probably not be void, but probably should return attack damage. I'll give it a default return 0, and then in our player we can return that integer, and this could be whatever we want. So let's say let's say this player only has a spin attack, so we're going to say int spin. We'll do a private int spin attack damage equals 10. So then all we have to do here is return attack damage from the parent class plus spin attack damage. Really cool, huh? So the zombie has its own type of attack. The player has its own type of attack. The player is actually overriding the attack and then doing its own thing here. And this is the beauty of object-oriented programming. So what's cool is all your your classes can be different. Like you got a zombie here, for instance. If we wanted to take it further, we could add another class called like Acid Zombie or another class called Fire Zombie. And remember in Diablo how you'll see one character, but they've got like the hero zombie and they've got the acid zombie and the fire zombie. They've got all these different types of things, but they're almost all the same except each one does something different. And what they're probably doing is they have multiple classes so that inherit from zombie like fire zombie, acid zombie, things like that, that just slightly change things around. And if you think about the object-oriented programming model that I brought up earlier about blueprints and vehicles, it's kind of like that. If you order a Honda Accord, which I don't know why you do that. I mean, it's a Honda, but just kidding. As long as it's not a Civic, I don't care. So what you do is one car comes out with red paint and with power windows and with leather seats and an upgraded audio system, although their audio systems are terrible too. They don't really do that in Hondas for some reason. Anyway, that's one variant, right? That came from the Honda class. But there's another one, it's the Honda Accord, but this one is no power windows. It's cloth seats. All it has is a radio player, and it still can move, it still can drive, but has some slightly different things. And that's the beauty of object-oriented programming. Okay, and object-oriented programming is a lot easier to understand when it comes to games and other things because things are objects. They're moving around. They're doing all kinds of cool things. And so we've talked about inheritance and how they actually work, but we actually haven't created one yet. So it wouldn't be too hard to do that, right? We got a zombie, a player, and a humanoid. So what we could do is we can go back to our Unity. And what we're going to do is we're going to create a new script. I'm just going to call this Game Manager. Save and drag it onto the camera. Come on. It's kind of yelling at me here. All right, let's try this again. Game Manager onto the main camera. Perfect. Double click the Game Manager. Okay, so now we got an actual game here, but it's starting up, and we want to spawn some characters. How could we spawn some characters? Well, wouldn't be too hard, I suppose. We could just say zombie equals new zombie, like so. I think that's pretty awesome. And then we could do things like zombie.attack. Ooh, so here's something interesting. Remember the zombie attack, or remember the attack function right here? Okay, let's actually return the attack damage instead of 0. It's returning something, right? So this is cool. Ooh, this is really cool. What we can do is go back to our game manager. Let's create our player as well. Say player equals new player. So anytime you create an object, anytime you instantiate a class or you're creating an object, use the new keyword here. Okay, and so what we want to do is we want the zombie to attack the player. Okay, so let's go look at our humanoid. Do we have any classes that can inflict damage? We don't. So let's do one of those now. We'll say public, virtual, and we'll say void, take damage. And this is going to be int damage to take. And this one's going to be health minus equals damage to take. Okay? As you can see right there. Just a simple function. Now we can go back to our game manager. This is really cool. So we can say right here, player.take damage, and we're going to pass in zombie.attack. So what's going to happen is it's going to call in this humanoid class, it's going to call the attack function, which is going to return a damage to send back. Okay, and then that's going to go into the take damage function, which is going to take health away from the player. How cool is that? Okay, player.take damage, zombie.attack. So it brings us the attack. Okay, and we could do it again too if we want to. Player.take damage. This time we can say zombie.acid puke attack. Right? Pretty cool. And then let's say it was time to die. We could say player.die. Okay. So this is how you can start working with classes. So think about this. If you wanted 100 zombies, it would be as simple as doing something like this. We could say zombie, an array, and we'll call this zombies equals new zombie. And let's say we want 100 zombies. All right. Then we can make a for loop for int x equals 0 at x is less than, let's say zombies.length x plus plus. Okay, and then we could actually say zombies x equals, we're going to say new zombie, like so. Okay, so we're just going to assign it into the slot. And then we can even just do a quick debug. Debug.log creating zombie number. Actually, let's use the pound sign number and plus. Actually, we don't even need a space. We'll just say plus x. Okay, so what would happen here is, well, we can do it. If there's no crashes, let's see what happens actually. Many crashes? No, looking good. Okay, go to the console. Creating zombie 95, 96, 97. Now keep in mind we're not using the mono behavior when we create a new zombie. We're not doing it the Unity way. We're just doing it the pure C# way. And I'm just trying to teach you C#, so don't mind these warnings for right now. But look at 94, 93, 92, 91. It just created 100 zombies. Okay, we just used the for loop. It created 100 zombies, which is pretty cool. I think it's pretty cool actually. If we wanted to actually make this into a real game object, okay, I'll just show you how to do that as well too. That's for another lesson. We're going to do that 100 times. So is this starting to make sense? Kind of like cars and blueprints, you know, zombies, players, humanoids. It takes a little practice to get, but one thing that'll help you is if you start thinking about objects. Like if you're creating a game, if you're creating the next My Little Pony game, okay, and you're creating a pony, Pinkie Pie, okay, you got to stop and visualize. Close your eyes and visualize. What can she do? What attributes does she have? Well, she has a happiness level. Okay, it's a video game. She has a happiness level. Maybe it's trying to make her sad or happy, or she doesn't have a party. She gets really sad. And then total amount of cupcakes she can eat. You know, color of her eyes, her skin color, and then there's actions that she can do like make a party. You know, be loud, and obnoxious. So there's attributes on objects, and then there's actions objects can take. Attributes are like things that describe the object, and actions are the things that the object can do. A vehicle, okay, some of its attributes can be that it's red, that it has a V8 engine in it, that it is a manual transmission or automatic. And the attribute or the actions it can take are drive, turn, roll down windows, stop, okay? So that's how you can start thinking about objects in all of your games and things like that. It's a deep subject, it goes as far as you want it to go. You're going to learn a lot about this just naturally as you start building your games. It all comes together and starts making sense. But that's all for now. We're not going to talk too much about it anymore. It's just time to get in the code. The more you code, the better you'll get. That's it. Mark Price at devslopes.com, signing off.